Okay, now for the chapters 10 through 12 review. Each of these chapters is pretty small, that's why I lumped 3 of them together. So with this data, the GPA, hours of work, and how many units people are taking, this is actually meant to be one long list of data. So it's a grand total of 32 people, but it just fit on the page better by splitting it side by side. Okay, so we're going to be doing a chi-squared test for independence to see if your GPA and how much you work are independent or dependent. So first of all, we need to take GPA, let's say, put it on this side. So just pick one variable and put it on a side. And then we have to decide how are we going to divide the data. Seems to me like 3.0 would be a good way to split GPAs, like above 3.0 and below 3.0. But what I want to make sure that I do is for these 32 people here, I need to split them by GPA pretty much evenly. 16 and 16 or something close to that. So I'm not sure that 3.0 would do it. What I can do is put the data in a list. And in fact, I'm going to need to do this for the later problems. So I already went ahead and did it. Here's the first person. You can see, there they are. So I've got the 32 people in the list. And then what I can do is find the average. So calculate for list 1, the GPA. Yes, 3.0 sounds like a good idea. So I'm going to go with less than a 3.0 and then bigger than or equal to a 3.0 GPA. Now I need to do the same thing for the work. So work is going to be this variable, and then how to divide the work. So I would think that 20 hours would probably be a good place, sort of half-time employment, but let's see. Find the mean and standard deviation for list 2. List 2 is the work, okay. Yeah, it's actually 22. So I'm going to use less than 22, bigger than or equal to 22 hours for the work. Okay, now what I'm going to do is go and highlight all of these people. You can either use a highlighter or just put a mark. I'm just going to put a mark. So it's below 3.0, so anything that's 1 point something or 2 point something. So I'll just put a little circle by those people with 1 point something or 2 point something. All right. And like I said, hopefully that divided it approximately 16 to 16. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, so it's going to be 15 for one and 17 for the other. That's pretty close to even. So just to keep track of that, that means this is going to be 15 total. And then the other people, that should be 17 of them since there's 32 people total. And then it's good to double check that real fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes. Okay. Next up, we've got to say, look at all of these people that we highlighted, and now find out how much they work. So you look at the highlighted people, and this person works more than 22 hours, so they would go over here. And then you can just put a little tally mark and count. And then you go to the next person. Yeah, they work a lot. The next one. So the next one here, yes, they work a lot. And that one works a lot, so that was 2 in a row. And then the next person, no. Doesn't work that much. And then 2 people in a row that don't work very much, and then 1 that works a lot. And then over here, let me see, the cutoff is 22, and if they equal 22, then they belong over here. So this is 2 in a row that belong over here. And then we're on to these people. There's 2 in a row that work a lot, and then 1 that does not work a lot, so that's over here. This person is below 22, so that's over here. And then 29 would be over here. And then we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. So this would be 10, and this would be 1, 2, 3, 4, 5. And that does add up to the 15. But I think that I would just go back and check real fast. Because there's so much data in here, it's quite easy to make a mistake. So let me just double check. I'm just going to count these people. I'm just going to count them if they're highlighted over here and if they work a lot. And let me see if I get 10 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so now I'm convinced that I have these numbers right. Then the next thing you do is go to the non-highlighted people and do the same thing. So you go through and make the tally marks, and then you make sure the two numbers add up to 17. You should double check. So to save a little bit of time, because this video is going to end up to be pretty long as it is, I'm just going to tell you I already worked this out, and this is 11 and 6 people. Okay, so the next thing to do is write out the claim, and that's that these two things are independent. That how much you work has absolutely no effect on your GPA. So the claim is that GPA and work are independent. And you don't have to put H sub O and H sub 1 and all of that. It's just that these two are independent. And then it's a chi-squared test. So the chi-squared distribution starts at 0, and then it's skewed like this. Also, it's a right tail only test, so it's going to be just this right tail. Since the level of significance was not mentioned, use 0.05, or in other words 95% level of confidence. And then we need to just look up the critical value and find the test statistic chi-squared. Okay, next, the calculator. So if you were to just automatically go over to tests and try to find the chi-squared test down at the bottom, so it's C, the chi-squared test. Well, when you do that, it says the observed values should be in matrix A. And then it's going to put the expected values in matrix B. So right now our job is to make a matrix A and put these values in there. So matrix is right here. Sorry, there's a glare, but if you can see, there it is in blue, matrix. So you need to, first of all, quit this statistics part, and then go to second matrix and move over to edit so that we can edit the matrix. And this matrix has 2 rows and 2 columns, so that's 2 by 2. And then enter this data. So you just hit enter each time. There we go. All right, now we're done with the matrix part. We can go back to the statistics. So quit the matrix part, go back to the statistics tests, and there's chi-squared. Okay, now it's all set up. All you need to go do is calculate. So the chi-squared turns out to be a 3.137. So that's the test statistic. 3.137. And by the way, because you have a choice of how to divide this, the only stipulation being that it needs to divide it pretty evenly, Someone else might say, well, I'm going to put this as 3.1 and 3.1, and then these numbers would be slightly different. Consequently, the test statistic would be slightly different. That's perfectly okay. Being slightly different is perfectly okay. In just a moment, I'll show you where you could go wrong if you don't split these evenly. Like, for example, if you said, well, I'm going to use a 1.0 GPA and a 1.0, and you're going to have 0 people in this category and you're going to have 32 people in this category, then the results are not going to be valid. But I'm going to show you in a minute how you can check and see, are the results going to be valid. We just need to finish this part right here. So next up we need table A4, the chi-squared table. There's my pretty artwork. And we need degrees of freedom, which is the number of rows minus 1 times the number of columns minus 1, or you can just get it from the calculator. Degrees of freedom is 1, and it's 0.05, so that means that degrees of freedom is 1. 3.841 is the critical value. So 3.841, and then that lands close to it, but no, fail to reject is the result. So fail to reject the claim. And so that means there's not enough evidence to prove anything. All right, now for the last part, which is required, and that is you go and take a look at the matrix B where the expected values are. The idea of the expected values are, if this is true, that GPA and work have nothing to do with each other, then what we would expect is the numbers to look like matrix B. So just go to the matrix part again, second matrix, move down to matrix B and hit enter. Once it's on the screen, hit enter. So in theory, it should have been split very evenly like this, 7.5, 7.5, 8.5, and 8.5. And that you include in the matrix in parentheses. So in theory, it should have been like this. So of course you can't have 7.5 people doing something, but in theory, that's how it should have been, how the 32 people should have been distributed very evenly. So this basically says, well, there isn't enough evidence to prove it, but by looking at this and this, it looks like, you know what, there is something going on. Maybe if we had 82 people instead of 32 people, we would have enough evidence to prove it. But with this, we can't prove anything yet. All right, now, because that one was rather challenging, and because I also want to see, well, does the work have an effect on how many units, we're going to do the same thing again. So again, you can find the average and use that to divide the units, which is 12. So we'll go less than or equal to 12, and then bigger than 12. And again, work is still 22. So less than 22, bigger than or equal to 22. Oh, I forgot to say something on this last one. When I said that your numbers might be slightly different because you used a 3.1, and slightly different is not a problem. Over here you might have something like a 2.95 or something instead of 3.1. That's fine. When it gets to be too different, that's when all of these numbers in the parentheses, the expected values, need to be bigger than 5. If any of them is less than 5, then the results of the test are completely invalid and you need to redo it. So you'd have to split them up again so that it is split more evenly and all of these expected values are above 5. Okay, then back to this one. So then you go through and let's say count these people right here, the ones that work less than 22 hours. and so you go through and put a mark by them. I need to use a different mark, so I'll check mark them. If it's less than 22 hours, let's see, what did it say? Less than, not less than or equal. So this person doesn't get counted right now. I'm looking for less than 22. Okay, so that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people. So in this less than 22 hours, that would be 16 people. So actually that was a great way to split it, because that would be 16 and 16 to make 32. I can even double check that right now. So those people that work a lot, they don't have a check mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sure enough, it's split 16 and 16. And then for these people that I have, these people right here that I've put a check mark by for working less than 22 hours, then find out how many have less than or equal to 12 units. So for the check mark people, then how many have less than or equal to 12 units? So 1, I think I'll put a different mark. 1, 2, less than or equal to, so 3, less than or equal to 12 units. This one and this one. No. And so it looks like we just have 1, 2, 3, 4, 5. So there's 5 people in this category. And that means that there should be 11 people in this category. Excuse me, I need to move the paper up. So since the total is 16, there should be 11 people here. The ones that have a lot of units, over 12 units. Let me double check that. So they have to be check marked because they're not working a lot. Then do they have a lot of units? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Exactly. So there's 11 of them. Okay, so now you go to the people that are working a lot. So that's the people that are not check marked. And then they've got less than or equal to 12 units. So the ones that are not check marked, and then count them if they don't have a lot of units. So there's 1, 2, 3, 4, 5, 6. I think that I skipped that person. Okay, start again. So this is the people that are not check marked, and then less than or equal to 12. So even at equals 12, I do count them. Here we go. Sorry if it's making you dizzy with the paper going up and down like that. So this person, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So there would be 14 people in this category, which leaves 2 people for the other category. So there's only 2 people that are working a lot and taking over 12 units. Let's see. Who are they? Working a lot and taking, there's 1. So you got 1 right there, working a lot and taking over 12 units. Who else? Right here, working a lot and taking over 12 units. Those are the only 2. So that's those 2 people right there. Okay, then the rest of the part, I'm going to speed up a little bit. The rest of the work is done just like this. So the claim is that the units and work are independent. And then we've got the chi-squared distribution. It's going to be 0.05 again. Use 95% level of confidence, which means that the critical value is going to be the same, 3.841. And then for the test statistic, well, we're going to need to go in and change matrix A. So right here, go back to matrix. So second matrix, edit it, edit matrix A. And then this one is 5, 14, 11, and 2. And then quit, get out of the matrix stuff. Go back to the stat tests. And there's chi-squared. So the setup is the same there. Calculate, and this time the test statistic is 10.494. Which lands way, way over to the right. So since it goes past a 3.841, that means that definitely reject the claim. So that means that these two things are not independent. That means they do depend on each other. So if you work a lot, like these people, then there's only two of them that could take a lot of units. They work a lot. Most of them don't take very many units. So work and the number of units are dependent on each other. If you work a lot, you're not going to be able to take a lot of units. That makes sense. Okay, on to the second page. So testing for a linear correlation. So that's to see if there's a direct relationship between GPA and work. But what linear correlation does is, so these are, if you remember, column 1 is the GPA, column 2 is the work. So the GPA and the work. So then what it does is it takes these pairs and tries to see if there's a line that would go through them. So in general, you could take a look at the picture and basically you could plot all of those dots and basically see as the GPA goes up, does the work go up? Or the other way around. But in general, is there a linear pattern? Is there a line through those dots, or are they just scattered, randomly scattered? Okay, so the test is very easy to do. You go to stat. This time it's actually under calculate, and it's number 4, the linear regression. So it puts linear regression. It's right now waiting to see if you want lists other than 1 and 2, you would tell it that right now. Since I use list 1 and 2, I just need to hit enter and it will automatically go to list 1 and 2. So the R turns out to be a negative 0.261. So the R values always range between -1 and +1. And then, of course, 0 is in the middle. And then we'll look up the critical value. And then we found out that the R is equal to -0.216. I think a moment ago I said 0.261. Sorry. It's -216. Okay, now for the critical value. So that's table A6, and table A6 is actually the smallest, easiest table. You only have a choice of 0.05 or 0.01. With this problem, I didn't say, which means that you would use 0.05. And then you just need to know the sample size. Well, I remember from the previous problem that's 32. So you go here and there's a choice of either 30 or 35. You always use what's closest to what you want, so use 30. So that means the critical value is 0.361. So looks like I need a little more space. 0.361. And this one would be negative 0.361. And a negative 0.2 would land right about over here. And it's only if it lands way over here on the right that we would say that there's a positive linear correlation. If it landed way over here on the left, then we would have proved something, namely it has a negative linear correlation. But if it lands in the middle, then we proved nothing. So positive linear correlation would mean as your amount of work goes up, then your GPA goes up in general. So they both do the same thing, up and up, or work goes down, GPA goes down. Not that that would make a lot of sense. A negative, if it would have landed all the way over here, a negative correlation means they do the opposite. So as the amount of work goes up, then your GPA will go down, which makes more sense, but there wasn't quite enough data to prove it. So we've got no linear correlation. Now if you compare that with what we just did over here, so this compared GPA and work also. It also said we can't prove anything. It was sort of close, but not quite there. This one also was sort of close, but not quite there. So this is sort of saying, well, if you had more data, if you had 62 or 82 people, perhaps then yes, we would be able to prove as the amount of work goes up, people's GPAs are going to suffer. But at this point, it's not quite enough data to prove it. Okay, so now we do the same thing with how many units people can take and the amount of work. By the way, if you don't have the R on your calculator and it only has the other two things, then what you've got to do is go to the catalog, which is right here under the 0. So you go second catalog, and then you scroll down until you find diagnostics on. So get down to the D's, and there's diagnostics on, and hit enter, and then the R will be there when you do linear correlation. Okay, back to the data. So this time it's going to be units and work. So we're going to be using list 2 and list 3. You can say list 2 and list 3 or list 3 and list 2, and it's going to be the same as far as the linear correlation. So it's these two, list 2 and list 3. So stat, calculate the linear regression for second 2, comma, second 3, for list 2 and list 3. And this time the R is a negative 708. So we've got R is equal to negative 0.708, and then the critical value, well actually it's going to be the same because this is the same sample size and we'd be using the same table, so it's going to be critical value of 0.361, or on this side a negative 0.361. And then this negative 0.7 would land definitely over here by quite a bit actually, and that means there is a negative linear correlation. So we actually proved something. And so that means because it's negative, that means these two do the opposite. So as work goes up, the number of units goes down, which makes a lot of sense. If somebody's working a lot, 40 hours a week, they can't take a lot of units in general. Now, is this true for absolutely everyone? No. If this would have been a negative 1.0, that would mean perfect correlation. That means it works perfectly for everybody. This is basically saying, well, in most cases, this is what's happening. In general, this is what's happening. There are going to be some exceptions. Okay, so obviously work has the biggest effect on the number of units that someone can take. And actually you can compare the two of these, so then they back each other up. The chi-squared test said when you compare work and units, then definitely reject. Work and units do have something to do with each other. Like here, if you're working a lot, you can't take a lot of units. And then what's good about having multiple tests is here's a completely different way to do it, and yet the results are the same. As the work goes up, then people can't take as many units. And then on to the last idea. So this is about some basketball teams and how many points they scored. The idea is, are these three teams the same on average? So the claim is that the three are the same. So I could just call this group number 1, group number 2, group number 3. So is the average for the three groups the same? And with the analysis of variance test, you can then test that claim all at once, and you can do it rather quickly. So you first of all need to enter the data in the list. There we go. Go away, glare. Go away, glare. There we go. Okay, so there's all of the points. I entered those in the list. And then the next thing is under stat tests. Actually the last test is the analysis of variance. That must mean we're getting close to the end of the semester. Okay, so then analysis of variance, and then you just have to tell it list 1, list 2, list 3. So second list 1, comma, second list 2, comma, and list 3. And then it's going to give you a whole bunch of information. Mostly what you need is this right here, which is the test statistic, 0.408. So we've got, it's going to be an F test, which looks like the chi-square distribution. It's right tail only, so we're going to have 0.05. We've already got the test statistic, which is capital F, which stands for fun. And it's a 0.408. Then I need to get the critical value. So that comes from table A5 is the F distribution. And table A5 is found in the back of the book. Unfortunately, it's one that we use, but is not on this nice formula chart. So you can either get it from the back of the book if you have a physical book, or if you have only the digital copy of the book online, which is what I used. I just went to the tables in the Appendix A and I printed it out. So with this one, you need to have 2 degrees of freedom, and we can get that right here. So the first degrees of freedom is right here, a 2, and the second one is right here, 27. So we need a 2 and a 27. So degrees of freedom 1, you use first of all and find out, okay, 2. And then degrees of freedom 2 is what this is talking about, is the 27 right down here. And then find out where the 2 and the 27 meet. And I don't know if you can see it, but it's 4.24. Oh, so it's a 42, 42, 1. So critical value is a 4, 2, 4, 2, 1. All right, then this lands way over here, because actually this starts at 0. 1 would be about right here, and then the critical value is way over here. So this is actually so small, it's so close to 0, since it's less than 1, you can accept the claim as true, that it seems that on average they are the same. If this would have been like a 5.4, then it would land over here, and then you could say, no, they're not the same. There's at least one team that's different than the other two. And if it were to land in the middle, then you can say, failed to reject, we weren't able to prove anything. All right, so this one, accept the claim as true. The three teams seem to be equally good, at least based on this data. The last thing to do is write down the mean and standard deviation for each group, each team. So one variable statistics for the first one. So the average is 116.4 and the standard deviation is 69.287. And then do the same thing for list 2, and the average is a 153.2 with S equal to a 108.501. And then finally for list 3, one variable statistics for list 3, a 156.1 with the S equal to 139.548. So you might look at that and say, well, these guys are in the 150s and these guys are only 116 average points. So it seems like Miami is a lot worse. But look at the amount of variation these have. It's a huge standard deviation. So if this could very easily vary by 108 points, then if it went down by 108, then these guys would be looking golden. So it's because there's such high variation in here, that's the reason that we're getting this result over here.